Hey guys, Mr. Riz here to help you out on the first day with the Hyperbolas. So make sure you guys have the guided notes. If you don't have them, you can always download them up here. We'll be kind of looking at them today, but with these guided note packets, we're going to try to do more exploring before we jump into doing, if we look at this here, if it pops up, all the little formulas and details that we'd have to worry about Hyperbolas. So first off, hyperbolas, if we look at their shapes, there's a lot going on in this picture, but pretty much all you will see are two parabolas, either one of them, and they reflect off each other. It's kind of hard to do with hands, but they kind of go either both ways, left and right, or both ways, up and down. That's kind of good. The asymptotes here are diagonal axes that kind of like show the direction of it. We have focus points too, but let's just kind of look more at a graph today. So I'm going to kind of walk you through the interactive website. So if you're doing this on your own and you need video guidance, hopefully that's why you're watching this video here. So what you have today are part 1 and part 2. So the interactive website here, kind of like the interactive website that we did with the ellipses. So let's take a look at that here. So first thing you're going to do is go to this one here. You're going to click on the student preview and then click next to go to the second slide. All right, so it's going to pop up here. We're going to click student preview. We're going to click next. My face was blocking it to go to the second slide. Okay, so hopefully we get to a slide that looks like this here. All right, we're going to use the C slider. The C represents the distance between the focus point. If C has a diameter length of 1, okay, what shape would the foci point make? So we're going to look at first here. Maybe, it'd be good to kind of split screen these. And that's coding class. Yeah, we don't need that. There we go. Yeah. Let's move this over here. Here we go. So we got questions on one side. We're going to use C. All right. So if we make C equal to 0, what shape is that? That's a circle. All right. What about if we make C bigger than 0 and less than 1? Okay. What shape is that? We're looking just at the black part here. All right. That would be an ellipse. What about C equal to 1? There is no black shape there, right? There's no shape. All right, any C greater than 1? All right, we end up making that hyperbola. All right, so what shape does a hyperbola kind of look like? It looks like a parabola. It's a hyperbola. All right, next we're going to go click several times to go to slide 6. So we're going to go over here to slide 6. It should look like this one here. All right, we're going to change the C slider by going through. We're going to study how the dotted lines relate to the hyperbola shape. So as we go through and change the C slider, we can see the dotted lines. How do they change the hyperbola shape? All right, what is you noticing about the properties of hyperbola, such as the asymptotes, the vertices, the center, and the foci? So we want to name 2 things here. So basically, if we make C bigger, that makes the focal points get bigger, right? Well, as the focal points are further away, we can kind of see a couple things. The parabola definitely gets wider, right? So as C gets bigger, that parabola gets wider, wider, wider. If it's closer, the parabola is closer, shorter, 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 or skinnier, skinnier, skinnier. The asymptote is the line that represents the end behavior of the graph. The other thing we could probably look at, the center does not change at all, right? Center doesn't change, it's still there. The vertices are still there. Anything else do we notice here? What about the focal points that we're talking about? The asymptotes? Well, the asymptotes also, as C gets bigger, the asymptotes get steeper too. Those are those diagonal lines there. So there was just a couple things. All right, next we're going to click next twice, go to the 8th slide here. It should look like this one. All right, so below is the standard equation for a hyperbola here. X minus h squared over a squared minus y minus k squared over b squared. So very similar to what we did, right, with ellipses, but it's a minus sign in the middle. All right, so we're going to match the slider. What does h do? All right, so h translates the hyperbola horizontally, right? K slides it up and down. That's a translation vertically. All right, what about A? What does A do? Okay, well, A stretches it, right? All right, stretches it horizontally. And what does B do? Stretches it vertically. All right, so now go to the Desmograph, and we're going to try to create this one here. So we're just going to go straight to Desmo. All right. Let's go to the graphing calculator. So we got x minus 1 squared over 36 minus y plus 3 squared over 4 equals 1. All right. So what would you have to do to make the parabola open up and down instead of left and right? All right, so we got a couple of different options here. It says switch the A and B number. So let's switch this to 4 and switch that to 36. Okay, that did not work here. So that still is left and right. Okay, so we'll go back. What about switch the H and K number? So we'll make this x plus 3 and y minus 1. Nope, all I did was just kind of move over. So we'll go back to the original. All right, switch the x and y around. So we'll make this y for x. Oh, okay, that's switched around. And then let's just go back. What if we make this equal to 2 instead of 1? I doubt that would do anything different. No, that didn't change anything. So yeah, definitely we need to switch the x and y around. So this is going to be a good translation to what we're going to do next. Is if we notice that our equation starts out with an x, it's going to run along the x-axis. It's going to be a left and right. If we make the equation, like in our Desmos here, start out with a y, it's going to go on the y-axis. It's going to go up and down. Okay, so you guys can submit that quiz. Let's see if my answer key is still good. Oh, I have one unfinished one because I didn't grade it. Yeah, you guys have that one question that gets hand graded, so a 3 out of 4 ain't too bad. That's what you want. Hopefully you take some time here. Yeah, it's being a little weird. All right. What we want to do next is to determine these openings. So we can always use Desmos here if you are really lazy and wanted to go through here. Oh, click the wrong button. Click next instead of preview. All right, so what we want to do here is, given the graph, determine whether the graph opens up or down. So, I mean, you could go through and literally type in every single one, x squared over 81 over y squared minus 41. Okay, you can see that opens left and right. So that's a horizontal. If it starts out with x, it's horizontal. If it starts out with y, it's vertical. Pretty simple that way. All right, guys, have a great time. Enjoy this one. Hopefully this is an easy section. I think you guys will be doing all right. We're going to take this nice and slow. This could get real crazy, but we're going to keep it pretty easy. All right, so you guys have a good one.